Hey everybody, welcome along for another session at KipperTie here on our Unfiltered live stream. You'll probably notice a change. This isn't Bryce anymore. I'd like to you guys to welcome Jesper Osterman from LC Tech, who's joining me today.
Yep, thank you very much. Glad to be here.
Yeah, it's been we've had a fun day of talking technology and getting to grips with a few things. Obviously, you and I have been working together and talking quite a bit over the past few months.
Yeah, I look back, we had the first contact 2019.
Yep.
Just introduction, and then from October last year.
Yes.
We have been worked quite closely together.
Yeah, exactly.
Where we are today.
Yeah, so it's been an interesting process working with a company like yours. I think it might be the case that you've had quite a bit of exposure to the filmmaking industry, but unusually that's not as a product manufacturer in its own right. So how do you position yourselves?
Yeah, so we're based in Sweden. We develop our own products and manufacture our own products. So we started out as a display company, LCD. Mm-hmm. So people usually know liquid crystal from display.
Yes.
Started out simple dot matrix, simple segmented displays, and now TVs.
Of course, yeah.
But so we started over 25 years ago, manufacturing those, but extremely challenging to do display manufacturing in Sweden and sell.
Well, yeah, this was one of my very first questions was, surely they're not actually making stuff in Sweden, but we get that question about our own processes as well. So this is it's a fully domestic Swedish process.
Yes. So what made us stay in business was the transition from display products to high quality optics.
Right. Yeah.
So we use the same materials, same manufacturing line, but have perfected it for optical products.
Yeah. And I think maybe the thing that all of us in the cinema industry don't necessarily understand or necessarily appreciate in the same way is there's a huge amount of other highly technical, highly complex optical markets out there. Some of them really not what you might expect. What sorts of areas, I mean, not necessarily, don't go in lots of detail, but what kinds of places have your products ended up in that sense?
So the first big success, 2010, 11, 12, was a polarization modulator, polarization switch for 3D cinema projection.
Right.
So showing left and right eye images time sequentially. So it was, we worked with US company, still work with them, Lightspeed Design, outside Seattle.
Yeah.
So we manufacture the filter itself and then make the mount and the electronics and the interface and sell it.
Yeah. So that whole switching process, which is inherent to making that work.
So that was the first big success that we had when 3D cinema boomed.
Yes.
Everyone should have it. So we have, I think, over 4,000 screens installed worldwide.
Yeah, great stuff.
And so that is one type of product we do, polarization switching.
Yeah.
We also do optical shuttering, so open-closed. So we find some industrial application.
Yeah, of course.
Like eye protection during microscope welding. And then we always look for new applications.
Of course.
What can we do with our technology? Where does it fit?
Yeah.
And we can attenuate light, that also we can do. So we looked at where is that used, and then we found out, so high-end cameras use ND filters.
Yeah, absolutely. And there obviously starts quite a long journey. So something that I'm interested to know is, I've obviously been in contact with you over the years at different points and seen different iterations of product. I think here at KipperTie, we've probably got a bit of a reputation for being quite demanding about how things should work, how things should be. And I've definitely been on the side of the fence that would say, I'm not sure that an electronic ND is really going to do what we need.
Yeah.
Have there been big leaps forward, or has this been a case of little by little making improvements?
Both, I would say.
Yeah.
We have started with it was 4 millimeter thick, I think 2014, our electronic ND. And then it was, not very good, maybe equivalent to mechanical rotating polarizers, but electronic control. And then we made, then it was polarizer based. Then
Yeah.
we switched to a different technology, working with dies. So that was one incremental step in the
Yeah.
improvement. The first was 4 millimeter, got not so much traction. Then we were down to 2 millimeter, and now we can down to 1 millimeter.
Yeah. Yeah,
So that is one very important feature, the thickness.
absolutely. Yeah.
And then also like color shift when you change the level of ND.
Yeah.
Now we have minimized it, so it's almost neglectable.
Yeah. Yeah. Absolutely.
Image quality, have everything parallel. And also, of course, cost-effective manufacturing and high manufacturing yield.
Yeah, exactly. So yield, as much as anything else, is something I think people are, more aware of these days. Actually, with that type of work, seeing actually reliable results from a manufacturing process. Probably the part of it that I think people understand least would be what the actual liquid crystal technology is doing in order to attenuate the light. So I think my read on it most of the time is when somebody talks about a liquid crystal device of some kind, they either think of a TV, millions of little pixels, lots of detail, lots of technology happening, or they think about it in terms of something very basic, their Casio watch from the 80s, or or maybe an alarm clock display with a transparent LED LCD screen. So where on those kind of scales do we lie to make an ND, and what is it that's different that means that the expected problem around polarization isn't happening?
Yeah. So it's partly around the driving, how you drive it. So the TV, you have an active matrix device, so a TFT transistor controlling the intensity of each pixel.
Yes, so every single one is doing a different thing.
Yes, on the Casio you have the large segments, you control segment by segment.
Yeah.
So basically our END, it's a single pixel device.
Right.
Yeah.
Yeah. So that is just one giant pixel looking at you.
And then, so the basic liquid crystal material, it's not so different in this, in our product, in the Casio, in the TV screen.
Sure.
Yeah.
Okay. So what is it about the method of construction that means that in some cases, if you are a user of cinema cameras from different brands, you'll have used the electronic ND, found it incredibly useful in some scenarios, but almost certainly people will run into issues with polarization, and they'll see issues particularly around something that's actually kind of ubiquitous these days, filming where there are screens, mobile phones, TVs, watches, there are screens everywhere, and they can become problematic. One of the things, and there's a list of good stuff that I've seen with your technology, but one of the primary things I've seen is I can still make use of a circular polarizer. I can still do things that I would normally do without interacting.
So our END is not sensitive to polarization at all. So we are using a not polarized technology. We are using so-called guest host technology, where the host is the liquid crystal material itself. So liquid crystal, you have a orientational order. That is the crystal part. So you have long cigar-shaped molecules, pen-shaped, that align parallel to each other, but they can flow around like a liquid. And then you can control the orientation by electric field. So in one state, you can have them without voltage applied, they are parallel to the surface. And then when you increase the voltage, you start to rotate all molecules. So that is the host material. Then we add the guest, which are dichroic dyes. So it's like most simple, you can compare it to a printer. So cyan, magenta, yellow, but we have more colors. And then those colors align with the liquid crystal. So when the liquid crystal rotates, also the dye rotates.
So it moves along with it, and you're then starting to
and then you have different absorption depending on the orientation of light. So without voltage, it's maximum absorption. And then when you start to increase the voltage, so it's a very low power technology, a few volts only, so milliwatt power consumption. Then you start to reduce the amount of absorption.
So the interesting thing for me as well was that one of the knock-on effects from that is we don't see a huge amount of issue with steeper ray angles, so wider angle lenses.
Right.
It's something that we still want to fully characterize for use in front of the lens. The products that we've been developing with you guys so far are our LC Mini ND that goes behind the lens, and we know that we have less issues there with ray angles in general, but nonetheless, that sort of issue with color vignetting is still something that we see on other manufacturers' solutions. Why is it that it's, I mean, obviously it may be something that still crops up in certain scenarios, but why is it less so with this method?
We have, so in general, because if you tilt the liquid crystal or molecules, you have different angles relative to the material if you come in, in different directions. So that has been, it was the same for display applications early on. Of course, you have a grayscale inversion. And
yes, that's it. I'm sure we can all remember looking at an early LCD screen. You walk around to the side and like you say, literally things would flip completely.
Yeah, so that was solved for the display with many pixels. You make the pixels average out. But for a single pixel device like ours, we invented and patented a design where you have two layers and they tilt opposite. So they average out, not spatially, but together when they are stacked.
So that stack presumably is part of why it's so challenging then to make a thin device, and thin is important for a bunch of different reasons. Right now, the product that we're pushing together is approximately 2 millimeter thick sandwich of material. We can actually go thinner, can't we? So a millimeter is, like you say,
the millimeter is the minimum today. And that seems to be small enough, low enough.
I mean, it's rare for glass to go below that thickness, not totally unheard of, but it's certainly thin enough that we're finding that the effects of that additional glass in the image chain are very negligible, which is really what we want to see. Jumping ahead from this then, I know this has been talked about around about a year ago. There is a next generational iteration of the concept in diffusion.
Yes. As I said, we have been working since 2014, or when we first announced the electronic ND, and it's starting to mature. We don't have so much more improvements to do. And we're always looking for new things to do with our line. We have a huge capacity in our manufacturing line. So then we looked into what more camera filters are there on the market, and then we found out diffusion. When we entered the ND, we didn't know anything about cameras. Some talked about E to EF. What is that? We had no idea of the most basic things about cameras, but we have learned. So then we came up with the idea that is patent pending on doing electronic diffusion. So it's same as the ND. It's totally continuous response. It's no discrete steps. And the switching is very fast with liquid crystal. You have some 10 millisecond range. So it's more instant.
Effectively instant, isn't it?
So that is, we announced it at the IBC conference in Amsterdam last year in September. And we are very glad that KipperTie is interested in this product.
I mean, it's part of what brought us to you is, specifically that diffusion concept. Diffusion is something that we've effectively championed to a great degree with various custom optical low-pass filters and other products of ours that employ diffusion as a concept. And because that's R&D that we did in-house, and because of the way I tend to think about things, and I want to get the science right as much as get the aesthetic result right, it felt like a really good fit. Obviously, this is something that is continuing to be developed. So there are things about that are at this point, lots of people will have seen it if they were lucky to see it in person or have seen it online. Obviously, that was very work in progress. The prototypes that we're looking at right now are improving iteration on iteration. And obviously, I'm very glad that we're being able to be involved in that process, give feedback, and to try and make sure that characterizing what that diffusion is matches up for a cinematographer. So because we've got that infinite variability, it actually puts some onus on us to decide, what should the controls be? What should we be allowed to do? How far should we push things? Like most diffusion, if you go beyond a certain strength, the results may not be aesthetically pleasing. And like most particulate diffusion, if you get to a certain point, there are diffraction effects on top of diffusion effects, and we start to see rainbows or unusual things that people might not want. My gut feeling usually with things like that is to put soft limits in place. But these are all things that we're going to work through as we continue to prototype it. I like to think that the professional user market that we address is smart enough to be able to take the guardrails off sometimes and say, oh, actually, I like that. I'm going to use this unusual effect that I get in a certain scenario. But like I say, that's something that fortunately, we can engineer on a very much in a sort of organic way because we've got this infinite variability. Usually when we make these kinds of choices, these are hard engineering decisions that we have to make. I'm deciding, okay, there are going to be these fixed components to this system. We have to make the right engineering choice. To a degree, some of that's mitigated by having the electronic control give us this greater variability. We can control things, well, for the ND as much as for diffusion, things such as what precisely does the curve look like as you ramp up through that diffusion? We can control things to give a specifically linear or non-linear feel, or we can quantify things better as well. So obviously, we're looking at wrapping that into our LC Mini ND product for behind the lens. It'll be working in front of the lens as well. So what people won't necessarily know is, as well as LC Mini ND drop-in filter, we're prototyping at the moment a matte box hosted filter. So literally a standard sized filter tray that will drop into a matte box containing your ND. In that instance, it's 1.5 to 5 stops.
The NDS
for the
in
ND.
front of lens.
So slightly different range. And obviously the diffusion will be working there as well. All of this stuff, I'm going to do an on-camera crossing of fingers because it requires engineering things to all happen in time, will be on display at IBC this year. So Jesper's going to have a stand with LC Tech and myself and colleagues from KipperTie, probably Natasha, who I'm sure a lot of our customers will have spoken with and will know, will be on location with equipment to show and stuff to demo.
Yes, we invited you to your booth, and we are very glad you accepted, because we do not sell to the end user. We don't make the end user product, we make the filter itself.
Yes, exactly.
But then we rely on other companies like you to make the integration, electronics, mount, branding, control.
Yeah, exactly. So yeah, it's something we're really looking forward to, actually. It's very nice to integrate a product where we get good data and good manufacturing quality. I have to say that's something that I found very useful, very helpful in this process. So kudos to your team for managing that.
Thank you.
It's, for example, so I've talked before on the live stream about how with the LC Mini ND, and it'll work the same front of lens as well, we're able to get a really precise calibration. So we know that when you dial in, ND 0.6, that is exactly what you get. And when you say 1.2, that is precisely what you get. And every step in between is just so. Most of the reason that we're able to do that is that we can take data that you've gathered in manufacturing, translate that through our driving protocol, profile it for our circuitry, and pass that on. Every single piece of glass is serialized. Every single piece of glass is characterized properly.
Right, each unit comes with a lookup table.
Yeah. So this is it's sophisticated stuff, really. It's I think it's possibly the type of thing that the end user doesn't always need to know that it goes on, but it is the difference between a good product and a bad product. Really, it's the difference between when we've got the ability to fine tune and control these things. It's fantastic to have not just that ability, but the data to back it up as well. So yeah, things that we'll be bringing to IBC that you guys will be able to come to the LC Tech stand and take a look at. Our LC Mini ND, which is literally on its way to shipping right now. We've got first batches of production stuff underway. We'll be showing front of lens filtration. We're pretty sure we're going to be calling that an LC Cine ND, if that doesn't make too much of a tongue twister for everybody, but Cine seems appropriate for the front of the lens product. There'll be diffusion and ND versions of that to take a look at. We'll be showing, with any luck, some diffusion behind the lens as well in that same drop-in.
Yeah, I brought the first samples today, hand carried, fresh from manufacturing.
That's it. So we're going to be doing our best to make sure that gets integrated and on show. And we'll also be showing a couple of things, one of which you guys will have seen if you're paying attention to the live stream, which is the Revolver LC. That's a Revolver compatible cartridge that contains a clear and the LC technology all inside one unit. So you can switch instantly to clear if you need to. And we're also going to be showing a product we'll be calling Adapter LC. And that is effectively a range of mount adapters. So from RF or E or L or Z mount to EF or PL mount. But those will be built around the Canon style drop-in filter. So that means that you can use our LC Mini ND inside a mount that's designed and built by KipperTie, as opposed to just your regular Canon RF to EF mount, which is very practical, but it is a consumer type device. These will be top of the line, high quality machined devices, and will pass electronic lens data, will have a back focus mechanism to allow you to adjust PL back focus without replacing shims, various other good stuff like that as well. And all of that we're aiming to wrap together at a price point which literally yet to be announced. Yeah. It's a topic that we're trying to sort of drill down to get the best possible deal for the end customer. And
your same product adapter will take both the END and the electronic diffusion?
Yes,
it's interchangeable.
Exactly. So just interchange. Yep. A clear filter if you want, electronic ND, electronic diffusion. It's showing real promise, I have to say. I'm very glad that we've kind of managed to get together on this. And I won't give anything extra away, but it is lovely to be able to say that having had a day together as opposed to just on Zoom calls, there's future potential as well.
Yep.
There's more to come than just
new
what we're
ideas came today from
exactly.
our discussions.
So really, really excited about that too. That's probably all the tease that you're going to get from me on that one right now. So you can watch this space for a bit more. Looking forward to seeing you again when it comes to IBC. If anybody, I don't know if we had any questions, Aaron. Nobody's dared interrupt, which is very good. We'll absolutely look forward to seeing you there. We'll have new exciting stuff to show. Thank you for joining me on our live stream.
Yeah, thank you for inviting me.
Yeah, no problem. Right, cheers everybody. We'll see you next time.
Thank you.